Radio navigation. Advances in navigational radio receivers installed in aircraft, the development of aeronautical charts which show the exact location of ground transmitting stations and their frequencies, along with refined flight deck instrumentation, make it possible for pilots to navigate with precision to almost any point desired. Although precision in navigation is obtainable through the proper use of this equipment, beginning pilots should use this equipment to supplement navigation by visual reference to the ground, pilotage. This method provides the pilot with an effective safeguard against disorientation in the event of radio malfunction. There are 4 radio navigation systems available for use for VFR navigation. These are VHF Omnidirectional Range, VOR, Non-Directional Radio Beacon, NDB, Long Range Navigation, LORAN-C, and Global Positioning System, GPS. Very High Frequency, VHF Omnidirectional Range, VOR. The VOR system is present in 3 slightly different navigation aids, NavAids: VOR, VOR-DME, and VORTAC. By itself, it is known as a VOR, and it provides magnetic bearing information to and from the station. When DME is also installed with a VOR, the NavAid is referred to as a VOR-DME. When military tactical air navigation, TACAN equipment is installed with a VOR, the NavAid is known as a VORTAC. DME is always an integral part of a VORTAC. Regardless of the type of NavAid utilized, VOR, VOR-DME, or VORTAC, the VOR indicator behaves the same. Unless otherwise noted, in this section, VOR, VOR-DME, and VORTAC NavAids are all referred to hereafter as VORs. The prefix omni means all, and an omnidirectional range is a VHF radio transmitting ground station that projects straight-line courses, or radials, from the station in all directions. From a top view, it can be visualized as being similar to the spokes from the hub of a wheel. The distance VOR radials are projected depends upon the power output of the transmitter. The course or radials projected from the station are referenced to magnetic north. Therefore, a radial is defined as a line of magnetic bearing extending outward from the VOR station. Radials are identified by numbers beginning with 001, which is 1 degree east of magnetic north, and progress in sequence through all the degrees of a circle until reaching 360 degrees. To aid in orientation, a compass rose reference to magnetic north is superimposed on aeronautical charts at the station location. VOR ground stations transmit within a VHF frequency band of 108.0 to 117.95 MHz. Because the equipment is VHF, the signals transmitted are subject to line-of-sight restrictions. Therefore, its range varies in direct proportion to the altitude of receiving equipment. Generally, the reception range of the signals at an altitude of 1,000 feet above ground level, AGL, is about 40 to 45 miles. This distance increases with altitude. VORs and VORTACs are classed according to operational use. There are 3 classes: T, terminal, L, low altitude, and H, high altitude. The normal useful range for the various classes is shown in this table. The useful range of certain facilities may be less than 50 miles. For further information concerning these restrictions, refer to the Communication NavAid remarks in the AFD. The accuracy of course alignment of VOR radials is considered to be excellent. It is generally within plus or minus 1 degree. However, certain parts of the VOR receiver equipment deteriorate, and this affects its accuracy. This is particularly true at great distances from the VOR station. The best assurance of maintaining an accurate VOR receiver is periodic checks and calibrations. VOR accuracy checks are not a regulatory requirement for VFR flight. However, to assure accuracy of the equipment, these checks should be accomplished quite frequently and a complete calibration each year. Using the VOR. In review, for VOR radio navigation, there are two components required: ground transmitter and aircraft receiving equipment. The ground transmitter is located at a specific position on the ground and transmits on an assigned frequency. The aircraft equipment includes a receiver with a tuning device and a VOR or Omni navigation instrument. The navigation instrument could be a course deviation indicator, CDI, horizontal situation indicator, HSI, or a radiomagnetic indicator, RMI. Each of these instruments indicates the course to the tuned VOR. Course deviation indicator. The CDI is found in most training aircraft. It consists of 1. Omni bearing selector, OBS, sometimes referred to as the course selector, 2. A CDI needle, left-right needle, and 3. A to-from indicator. The course selector is an azimuth dial that can be rotated to select a desired radial, or to determine the radial over which the aircraft is flying. In addition, the magnetic course to or from the station can be determined. When the course selector is rotated, it moves the CDI or needle to indicate the position of the radial relative to the aircraft. If the course selector is rotated until the deviation needle is centered, the radial, magnetic course from the station, or its reciprocal, magnetic course to the station, can be determined. The course deviation needle also moves to the right or left if the aircraft is flown or drifting away from the radial, which is set in the course selector. By centering the needle, the course selector indicates either the course from the station or the course to the station. If the flag displays a to, the course shown on the course selector must be flown to the station. If from is displayed and the course shown is followed, the aircraft is flown away from the station. Horizontal situation indicator. The HSI is a direction indicator that uses the output from a flux valve to drive the compass card. The HSI combines the magnetic compass with navigational signals and a glide slope. The HSI gives the pilot an indication of the location of the aircraft with relationship to the chosen course or radial. In this figure, the aircraft magnetic heading displayed on the compass card under the lubber line is 184 degrees. The course select pointer shown is set to 295 degrees. The tail of the pointer indicates the reciprocal, 115 degrees. The course deviation bar operates with a VOR localizer or GPS navigation receiver to indicate left or right deviations from the course selected with the course select pointer. Operating in the same manner, the angular movement of a conventional VOR loc needle indicates deviation from course. The desired course is selected by rotating the course select pointer in relation to the compass card by means of the course select knob. The HSI has a fixed aircraft symbol, and the course deviation bar displays the aircraft's position relative to the selected course. The to-from indicator is a triangular pointer. When the indicator points to the head of the course select pointer, the arrow shows the course selected. If properly intercepted and flown, the course will take the aircraft to the chosen facility. When the indicator points to the tail of the course, the arrow shows that the course selected, if properly intercepted and flown, will take the aircraft directly away from the chosen facility. When the nav warning flag appears, it indicates no reliable signal is being received. The appearance of the heading flag indicates the compass card is not functioning properly. The glide slope pointer indicates the relation of the aircraft to the glide slope. When the pointer is below the center position, the aircraft is above the glide slope, and an increased rate of descent is required. In some installations, the azimuth card is a remote indicating compass. However, in others, the heading must be checked occasionally against the magnetic compass and reset. The RMI is a navigational aid providing aircraft magnetic or directional gyro heading and VOR, GPS, and automatic direction finder (ADF) bearing information. Remote indicating compasses were developed to compensate for errors in and limitations of older types of heading indicators. The remote compass transmitter is a separate unit, usually mounted in a wingtip, to eliminate the possibility of magnetic interference. The RMI consists of a compass card, a heading index, 2 bearing pointers, and pointer function switches. The 2 pointers are driven by any 2 combinations of a GPS, an ADF, and/or a VOR. The pilot has the ability to select the navigation aid to be indicated. The pointer indicates course to the selected nav aid or waypoint. In this figure, the green pointer is indicating the station tuned on the ADF. The yellow pointer is indicating the course to a VOR or GPS waypoint. Note that there is no requirement for a pilot to select course with the RMI, but only the nav aid is to be indicated. Tracking with VOR. The following describes a step-by-step procedure to use when tracking to and from a VOR station using a CDI. This figure illustrates the procedure. First, tune the VOR receiver to the frequency of the selected VOR station. For example, 115.0 to receive Bravo VOR. Next, check the identifiers to verify that the desired VOR is being received. As soon as the VOR is properly tuned, the course deviation needle deflects either left or right. Then, rotate the azimuth dial to the course selector until the course deviation needle centers and the to from indicator indicates to. If the needle centers with a from indication, the azimuth should be rotated 180 degrees, because in this case it is desired to fly to the station. Now turn the aircraft to the heading indicated on the VOR azimuth dial or course selector, 350 degrees in this example. If a heading of 350 degrees is maintained, with a wind from the right as shown, the aircraft drifts to the left of the intended track. As the aircraft drifts off course, the VOR course deviation needle gradually moves to the right of center or indicates the direction of the desired radial or track. To return to the desired radial, the aircraft heading must be altered to the right. As the aircraft returns to the desired track, the deviation needle slowly returns to center. When centered, the aircraft is on the desired radial, and a left turn must be made toward, but not to, the original heading of 350 degrees, because a wind drift correction must be established. The amount of correction depends upon the strength of the wind. If the wind velocity is unknown, a trial and error method can be used to find the correct heading. Assume for this example, a 10-degree correction for a heading of 360 degrees is maintained. While maintaining a heading of 360 degrees, assume that the course deviation begins to move to the left. This means that the wind correction of 10 degrees is too great, and the aircraft is flying to the right of course. A slight turn to the left should be made to permit the aircraft to return to the desired radial. When the deviation needle centers, a small wind drift correction of 5 degrees or a heading correction of 355 degrees should be flown. If this correction is adequate, the aircraft remains on the radial. If not, small variations in heading should be made to keep the needle centered and consequently keep the aircraft on the radial. As the VOR station is passed, the course deviation needle fluctuates, then settles down, and the to indication changes to from. If the aircraft passes to one side of the station, the needle deflects in the direction of the station as the indicator changes to from. Generally, the same techniques apply when tracking outbound as those used for tracking inbound. If the intent is to fly over the station and track outbound on the reciprocal of the inbound radial, the course selector should not be changed. Corrections are made in the same manner to keep the needle centered. The only difference is that the omnidirectional range indicator indicates from. If tracking outbound on a course other than the reciprocal of the inbound radial, this new course or radial must be set in the course selector and a turn made to intercept this course. After this course is reached, tracking procedures are the same as previously discussed. Tips on using the VOR. Positively identify the station by its code or voice identification. Keep in mind that VOR signals are line of sight. A weak signal or no signal at all is received if the aircraft is too low or too far from the station. When navigating to a station, determine the inbound radial and use this radial. Fly a heading that will maintain the course. If the aircraft drifts, fly a heading to re-intercept the course, then apply a correction to compensate for wind drift. If minor needle fluctuations occur, avoid changing headings immediately. Wait momentarily to see if the needle recenters. If it does not, then correct. When flying to a station, always fly the selected course with a to indication. When flying from a station, always fly the selected course with a from indication. If this is not done, the action of the course deviation needle is reversed. To further explain this reverse action, if the aircraft is flown toward the station with a from indication, or away from the station with a to indication, the course deviation needle indicates in a direction opposite to that which it should indicate. For example, if the aircraft drifts to the right of a radial being flown, the needle moves to the right or points away from the radial. If the aircraft drifts to the left of the radial being flown, the needle moves left or in the direction opposite to the radial. When navigating using the VOR, it is important to fly headings that maintain or re-intercept the course. Just turning toward the needle will cause overshooting the radial and flying an S-turn to the left and right of course. Course intercept. Course interceptions are performed in most phases of instrument navigation. The equipment used varies, but an intercept heading must be flown that results in an angle or rate of intercept sufficient to solve a particular problem. Rate of intercept. Rate of intercept, seen by the aviator as bearing pointer or HSI movement, is a result of the following factors: the angle at which the aircraft is flown toward a desired course, angle of intercept, true airspeed and wind, and distance from the station. Angle of intercept. The angle of intercept is the angle between the heading of the aircraft, intercept heading, and desired course. Controlling this angle by selection, adjustment of the intercept heading is the easiest and most effective way to control course interceptions. Angle of intercept must be greater than the degrees from course, but should not exceed 90 degrees. Within this limit, adjust to achieve the most desirable rate of intercept. When selecting an intercept heading, the key factor is the relationship between distance from the station and degrees from the course. Each degree or radial is 1 nautical mile wide at a distance of 60 nautical miles from the station. Width increases or decreases in proportion to the 60 nautical mile distance. For example, 1 degree is 2 nautical miles wide at 120 nautical miles, and 1/2 nautical mile wide at 30 nautical miles. For a given GS and angle of intercept, the resultant rate of intercept varies according to the distance from the station. When selecting an intercept heading to form an angle of intercept, consider the following factors: degrees from course, distance from the station, and true airspeed and wind. Distance measuring equipment, DME, consists of an ultra-high-frequency navigational aid with VOR DMEs and VORTACs. It measures in nautical miles the slant range distance of an aircraft from a VOR DME or VORTAC, both hereafter referred to as a VORTAC. Although DME equipment is very popular, not all aircraft are DME equipped. To utilize DME, the pilot should select, tune, and identify a VORTAC as previously described. The DME receiver, utilizing what is called a paired frequency concept, automatically selects and tunes the UHF DME frequency associated with the VHF BORTAC frequency selected by the pilot. This process is entirely transparent to the pilot. After a brief pause, the DME display shows the slant range distance to or from the VORTAC. Slant range distance is the direct distance between the aircraft and the VORTAC, and is therefore affected by aircraft altitude. Station passage directly over a VORTAC from an altitude of 6,076 feet above ground level, AGL, would show approximately 1.0 nautical miles on the DME. DME is a very useful adjunct to VOR navigation. A VOR radial alone merely gives line of position information. With a DME, a pilot may precisely locate the aircraft on that line or radial. Most DME receivers also provide ground speed and time to station modes of operation. The GS is displayed in knots, NMPH. The time to station mode displays the minutes remaining to VORTAC station passage, predicated upon the present GS. GS and time to station information is only accurate when tracking directly to or from a VORTAC. DME receivers typically need a minute or two of stabilized flight directly to or from a VORTAC before displaying accurate GS or time to station information. Please help us spread the word about Pilot Training System, and we look forward to further servicing your flight training needs.